Welcome to SEC presentation about human reliability analysis methods. In this presentation, I will promote the human reliability analysis, demonstrate some methods, and of course, application of the human reliability concept in reliability and safety analysis. My name is Dr. Eduardo Calixto. I am a reliability and safety expert as well as asset management specialist. Have 18 years experience in different fields and industries such as oil and gas, aerospace and defense, railway industry, mining, and have a degree of as an industrial engineer. Have a master in safety management and PhD in risk analysis for environment and energy program. That's the outline of this presentation. It's important to say that's one of the first time that this presentation is this topic is being presented in this conference in ARDC, the old ARS, and I'm very happy to have this opportunity. So this presentation will, as I mentioned before, start with some reliability, human reliability concept. After we go through some human reliability maths with some examples, and then in the end, I will present three case studies. The first one, consider the effect of human factor in system operation availability. So in this example, I will demonstrate after to carry out some human reliability analysis, how we can input such information in an RBD model. The second one is the effect of human error in system shutdown analysis. Very interesting case that was the objective was to demonstrate how to the importance to have automated shutdown valve rather than have it manual. And then all the human reliability analysis was support this type of assessment. The third one was the human factor effect on maintenance activity based on female result. And then we got our conclusion, and we will be able to see how important is the human reliability analysis in the context of reliability engineering program for different industries. My objective in this presentation is to demonstrate how easy and feasible is to apply human reliability. So my objective is in the end that you get some clear idea about some methods and see how easy is to apply human reliability and how important as well. So you can later on use this introduction looking for more information and of course applying your project and daily activities. So a little bit about ECC. I just gave some introduction about me, myself, my experience. Yeah, these companies are the companies that I work for and I'm working with. So start in Brazil in mining industry, oil and gas, work by Reliance Soft as a consultant, by Bombardier as an engineer. Then I moved to London and work for oil and gas, for Genesis Oil and Gas Consultants, work for BQR in ILS program reliability. Then I moved to Germany, starting to work with Build Philotech, Airbus, one specific project, radar system. And now I have some partners in Kelt that I support to develop the asset management solution, and some clients as Molinari and partner as well as Schindler. So basically ECC provides training and consultant service in different subjects: asset management, asset integrity, safety engineering, reliability engineering, and integrated logistics support for different industries such as energy that encompass nuclear power plants, oil and gas, chemical, railway, and aerospace and defense. And of course, other industries are always welcome to have some training and to be deliver some service. Our partner is Schindler. From Kindle, we developed together some consultants and service and training in China. Enkelt is our partner for asset management development solution, and Hams Engineering in asset management is our partner in UK to support the UK railway industry in terms of consultant and service. It will come in new partners from US in probably in next year. You see here. So a brief introduction about ECC team. We are all consultants as experts. So starting from me. So yeah, I already made my introduction. So the second one is Mr. Carl Butler, is expert in railway and aerospace and defense industry for maintenance and ILS. Mr. Fred Apo, he presented here also in this conference. He's an expert for RAMs, reliability engineering, asset management, predictive maintenance for railway industry and aerospace. So this we are three here are the ones that deliver solution for aerospace and railway. Mr. Hedges is the expert for um, design for reliability to develop products, meaning accelerating tests, house test, and this type reliability growth program. And below we have our partner Paul Stewart, also part of ECC team for oil and gas and process industry. And he is a specialist in backgrounds in platform oil and gas industry. Mr. Hal Palakodet is a specialist in power plants and also reliability engineer expert. Mr. Steve Scott, expert in inspections, basically for tanks and programs RBIs. And Mr. Alexandre is also expert in reliability engineering and inspection and maintenance and support us for oil and gas industry and process industry. So let's start some concept about human reliability. So basically, human error is a non-compliance in performing task. Human error probability is probability of human error. So you can say the number of error divided by the number of error opportunities. Sometimes to predict this index by based on database is hard, but you will see during the presentation that you have different qualitative methods and also tables that give this value for our assessment. Omission error is the action that is not performed because of lapse or misperception, basically when you forget to perform some task. Commission error is the action is performed incorrectly because of an incorrect quantity or quality of actions or a mistake in selection or proceeding with a sequence of tasks. So we have basically two types of error that is defined in context of human reliability. And human performance factors are the factors that take influence in human error. So for example, the ergonomy or the stress or the procedures or the supervisors, no, those are all human performance factors. And you see how to take into account the influence of such human performance factors in our analysis. And human reliability is the probability of human conducting a specific task with satisfactory performance. So human reliability is 1 minus human error probability. Okay, so just basic concept, we will go through more details further on. So basically, give a general overview of human error. Human error occur after you have some conditions, perform factor conditions, that the combination of such performance factors will trigger some type of omission or commission error that you, and considering the human behavior, you get a human error. Okay, so let's give a more structured picture, a view of the human error. So human performance factors is the factor that influence in human error. So we can have internal human performance factors such as psychological and physiological factors. So, or we can have external, that's social or technological aspects. So the combination of these aspects or one of them or more of them will trigger omission or commission error, and then you have human failure. The other very important point is that during when someone performs some task, we need to understand the type of behavior to perform this task. So basically, some tasks are based on procedure, other based on skill, other based on knowledge, and we need to take into account what is the behavior that is essential for a specific task in order to propose the proper recommendation to mitigate the human error probability. Okay, so let's go through the techniques, the different human reliability methods. So basically, we can say that on the very beginning, we start with methods that want to predict the human error probability. I will present these methods in detail in here, but you can see some of them. For example, technical for human error prediction was the first one, defined 1975. And after we have a human operator action tree, another one that we're defining here, and all these four methods I will define and go through details. But basically the objective here in the beginning was just to define the human error probability, and after that we can start to see in these two methods here that's the accountability of human performance factor is starting to take place. And then the second generation is starting to look on cognitive factors. So we'll see the cognitive reliability and error methods in this presentation. And the third one was to also consider the influence among the human performance factors and was the Bayesian network. So that's the last discussion and the last method implementation that we have concerning human reliability methods. It's important to say that all these human reliability methods are applied and defined in procedure. Most of such procedures were applied for nuclear power plants or aerospace industry, and many of them were defined in US or in UK. You can have access if you look for these methods, and there are a lot of papers. In the end, I will present some bibliography, and then you can looking for the specific procedures. So let's go through these methods now, and then I will explain one by one and give an example. So the first one is the technique for human error and hate prediction. So let's consider that we have a task that we need to perform some tube and shell heat exchanger is very common for human reliability. So based on the THERP methods, we need to define, as usual for human reliability analysis, the steps of the task that need to be carried out. And this task can be defined in this THERP events tree. So in one side, I'll put all the success probability, and the other side is the unsuccess probability. That's described for failures. So the sequence of the probability of the human error probability will be 1 minus the probability of success. So depends on the data that I have, I will use in this equation in here. So let's say that I have the probability of success, so I just multiply all of them. Is a sequence of activity. That means if one failed, I will fail the whole task. So in the end, I will have my probability, human error probability. The main question is, when I do not have a database, how can I get such information? And to answer this question, I show this template here. That is one of the examples that we have source of human probability error that we can, depends on the type of error and the performance factors, we can define some probability of error and inputting here. So for example, we are using 0.005 for the first human error probability here. So that means we consider the first test, checks and operators stop equipment, as this check is an omission error if they do not check, and have a long time to check, but they can forget or don't forget some step that need to carry out. So we define as omission error as a long time, so we get this value here. So it's one way to do that. If we have a database or we can elicitate specialist opinion about such probability, we can also apply in here. Just it's important to demonstrate that is an example of templates, but we have some templates, as you're going to see in my presentation, that demonstrate probabilities of human error, that you can have an idea or get such information to perform some human reliability study.